Continuing with the problem number 4 of unit bending stresses in beam. Problem number 4, the statement is in this way. A beam of cross section 100 mm by 200 mm is simply supported at both ends. It carries two concentrated loads of 100 kN each acting at 2 meter distance from each support. The span of beam is 7 meter. Determine maximum bending stress induced in the beam. This problem is asked for 9 marks. इस प्रॉब्लम में बीम का क्रॉस सेक्शन है रेक्टेंगुलर क्रॉस सेक्शन जिसका विड्थ है 100 mm और डेप्थ है 200 mm. So the cross section is simple, that is rectangular cross section. So neutral axis lies at the half of the depth of this beam, that is 100 mm from the bottom and 100 mm from the top. So we can find out the neutral axis position by observation. Now the loaded beam is given. The beam is simply supported beam and the beam is A, B, C, D. A and D end is supported end. The span of the beam is 7 meter and point load of 100 kN each is acting at a distance of 2 meter from each support, that is support A and support D. This point loads of 100 kN each is acting. So total span is 7 meter. Out of that 4 meter on both sides. So this span BC is of 3 meter. So this loaded beam diagram is given for finding out the bending moment acting on a beam. Now in this problem, we have to find out the maximum bending stress developed in the beam. So if we see, the loaded beam is given and the cross section of the beam is given. And it is asked to find out maximum bending stress developed in this beam. So this problem is very simple as compared to the other problems. Now, for finding out the bending stress, we have to use the formula, that is M upon I into Y. So in this formula, we have to calculate the maximum bending moment acting on the beam. And I is the moment of inertia of this rectangular cross section of the beam that we have to calculate. And Y max is in this problem is half of the depth, that is 100 mm. So very first step that we have to do is find out the moment of inertia of this rectangular cross section. So step 1, calculate the moment of inertia of this cross section about neutral axis. Calculate moment of inertia of this cross section about neutral axis. This is the very first step. So moment of inertia about the neutral axis, Ix or Na is equal to BD cube by 12. Neutral axis is nothing but the centroidal axis for this problem. So moment of inertia is width is 100 into depth is 200 cube divided by 12. So this moment of inertia we get 66.67 into 10 raised to 6 mm raised to 4. This is the moment of inertia of this simple cross section, that is rectangular cross section. Now second step for this problem is to find out the bending moment value. So the second step is calculate the maximum bending moment acting on a beam. Calculate maximum bending moment acting on a beam. So to calculate the maximum bending moment acting on a beam, we have to first find out the reaction. This is reaction RA and this is reaction RD. So here the loading is symmetrical about the center of the beam. So 100 kN load is acting on both sides and the beam is loaded beam is symmetrical. So in such case, the total load acting on a beam is 100 plus 100 is 200 kN and that is downward. So reactions will be half of 200 kN, that is each reaction is of magnitude 100 kN. So reaction in this problem is 100 kN each. 100 kN each. Now we have to consider the section at the center of the beam and find out the maximum bending moment value. So here we can see that the A end and D end is a supported end. So bending moment value at A and D is 0. Now we have to consider the section at B and consider the left part of the section. So bending moment acting at the point B, at the section B, is equal to 100 kN is the reaction into distance of that reaction from point B is 2 meter, and this moment moment produced by this reaction above point P is clockwise on the left side. So bending moment magnitude will be equal to 100 into 2. So this is 200 kilonewton meter bending moment value acting at point P, and that is equal to in Newton mm. We can write this value as 200 into 10 raised to 6 Newton mm. 10 raised to 6 Newton mm. So this is the bending moment at point P. Similarly, if we take the section at point C, सेक्शन सी पे अगर सेक्शन लेते हैं और सेक्शन का राइट पार्ट कंसीडर करते हैं, तो सेक्शन के राइट साइड में अगर बेंडिंग मोमेंट एंटी क्लॉकवाइज है तो पॉजिटिव. सेक्शन का अगर राइट साइड हम कंसीडर कर रहे हैं तो सेक्शन के राइट साइड में एंटी क्लॉकवाइज अगर मोमेंट है तो पॉजिटिव कंसीडर करना है. सो वी कैन कैलकुलेट द बेंडिंग मोमेंट एट पॉइंट सी by considering the right part of the section at C. So the reaction RD is 100 into its distance from point C is 2 meter. So this moment is also 100 into 2, that is 200 kilonewton meter, and that is also in Newton mm, it is 200 into 10 raised to 6. So this is the maximum bending moment acting on the beam. So this value of bending moment we have to take for the further calculation of the bending stresses. So bending moment value is, maximum value is this 200 into 10 raised to 6 Newton mm. Now we have to calculate the bending stress, maximum bending stress. As this cross section is symmetrical about the x-axis axis, so bending stress is maximum at the top surface as well as at the bottom surface. So maximum bending stress at the top or bottom surface. And at neutral axis bending stress is 0. So we have to calculate this maximum bending stress value. The formula is sigma B max. Sigma B max is equal to bending moment M divided by I, that is Ixx, into Y max. So total width of the beam for this problem is 200 mm. So Y max on the compression side and on tension side it is equal to 100 mm, half of the total depth. So Y max we have to take for this problem as a 100 mm. Y max we have to take as a 100 mm. So putting the values, we can calculate sigma P max is equal to, so bending moment value is 200 into 10 raised to 6 upon Ixx is 66.67 into 10 raised to 6 multiplied by Y max is 100 mm. So this value comes out to be 299.98. Maximum bending stress is, its magnitude is 299.98. This is the answer. And this bending stress is maximum at the top surface of the beam and at the bottom surface of the beam. Now we have to see the distribution diagram, bending stress distribution diagram. So we can see when the load acts on a simply supported beam bends in a concave shape. So when beam bends in a concave shape, the portion of the beam above the neutral axis is subjected to compressive stress, and the portion of the beam below the neutral axis is subjected to tensile stress. So bending stress distribution diagram for this problem is in this way. This is a reference line for marking the bending stress values. This is the neutral axis position, which is the centroidal axis of this beam, and on the top surface, bending stress is of compressive nature, and its magnitude is 299.98 megapascal. 299.98 megapascal. And at the bottom surface, the bending stress magnitude is same, that is 299.98, but it is tensile. Sigma BT max magnitude is same, but nature is opposite, that is tensile. So 299.98 megapascal. So this is the bending stress distribution diagram for this problem. And at neutral axis, bending stress is equal to 0. So as compared to previous problem, this problem is very simple and it is asked for 9 marks. The only thing is that we need to calculate the maximum bending moment value from the given loaded beam. And the maximum bending moment value is 200 kilonewton meter or 200 into 10 is to 6 Newton mm. From that we can calculate the maximum bending stress value, and that is 299.98 Newton per mm square. At the top surface it is compressive and at the bottom surface it is negative. So this is all about this problem. So thank you.